that with a change of variable, which is fine because it's asking you to find an equation with those roots. Next it says with roots alpha plus 3, beta plus 3 and gamma plus 3. So if I go back to doing the first method, I'd be using these results again, which is exactly what I found to do this question. I'd now be saying, right, the sum of the roots for this new equation would be alpha plus 3 plus beta plus 3 plus gamma plus 3, which would be minus b over a. Just from the identities that you should know, that would be alpha plus beta plus gamma plus 3, 6, not plus 9. So 2 plus 9, so 11 is minus b over a. For this version then, but with these roots here, I would have alpha plus 3, beta plus 3, plus beta plus 3, gamma plus 3, plus gamma plus 3, alpha plus 3. And that would be equal to c over a for the new equation. So what have I got? Alpha beta plus 3 alpha plus 3 beta plus 9 plus beta gamma plus 3 gamma plus 3 beta plus 9 plus gamma alpha plus 3 alpha plus 3 gamma plus 9. What does that work out to? So I've got alpha beta plus beta gamma plus gamma alpha, which is one of the things that I know. Then I've got 6 alphas, 6 betas and 6 gammas. So they're done. And 9, 9, 9, 27. So that one I already know is 3. This is the same as 6 alpha plus beta plus gamma. So 6 lots of 2 plus 27 equals c over a. So 42. And then for the product one, we're still on the page, I'm going to go below. So I'm going to have alpha plus 3, beta plus 3, gamma plus 3, which would be minus d over a. So if I do this one, I've got alpha beta plus 3 alpha plus 3 beta plus 9. Okay. If I multiply all of these by gamma then, I've got alpha beta gamma plus 3 alpha gamma plus 3 beta gamma plus 9 gamma, times it by 3, plus 3 alpha beta plus 9 alpha plus 9 beta plus 27. So I've got alpha beta gamma, which is I know. I've got 3 alpha betas, 3. Okay, so I've got 3 of each of these. So that's the same as 3 lots of alpha beta plus beta gamma plus gamma alpha. 1, 2, 3, they're gone. And then I've got 9 alphas, 9 betas, so 9 lots of alpha plus beta plus gamma plus 27. So if I know it's off the page now, but alpha beta gamma, we'd already worked out at the beginning, was 4. Alpha beta plus beta gamma plus gamma alpha was 3 from right at the beginning, and alpha plus beta plus gamma was 2. And if we work all of those out, we get 58, which is equal to minus d over a. Again, just like in this in the first example, there's not a denominator here, so we can say that a is 1. If A is 1, B must be minus 11. C is 42. And D is negative 58, which gives you equation x cubed minus 11x squared plus 42x minus 58 equals 0. Okay, so that's the first method you can use to do that. The second method we could use, which is the method of using a substitution, we could say, right, in the question, oh, it's lost focus. Can I get it back again? Come on. Ah, here we go. I've lost my train of thought. Oh, yeah. So in the original question, we had roots x equals alpha, beta, and gamma, and that equation was x cubed minus 2x squared plus 3x minus 4 equals 0. We now want to find an equation with related roots, so I'm going to call those related roots w's, which are alpha plus 3, beta plus 3, and gamma plus 3. How do you get from x to w? Well, w is x plus 3, which means that w minus 3 is x, and that substitution you can plonk straight back into there to get your related equation. So instead of using all those identities like we did in the first method, we can say, well, I'm just going to look at what the translation is or what the transformation is and pop it into there. So x cubed then becomes w minus 3 cubed minus 2w minus 3 squared plus 3w minus 3 minus 4 equals 0. So if I multiply this out, if I do 2, get w squared minus 6w plus 9 minus 2 lots. If I multiply that out in my head, if I multiply this out, if I finish this cubed one then, so I would have w cubed minus 6w squared plus 9w, times it by 3 minus 3w squared minus 18w minus 27. This one, minus 2w squared plus 12w minus 18 plus 3w minus 9 minus 4. So I've got w cubed here. That's done. Let's have a look at my w's. So I've got negative 6. My w squared, sorry. Negative 6. Take away 3. Take away 2. Minus 11. If I look at my w's, I've got 9. Take away 18. Add 12. Add 3. 6. We didn't have 6 before. What have I done here? 9 take away 18. Right, I've made a mistake here. So what have I done? W cubed minus 6w squared plus 9w minus 3w squared minus 18w. What have I done? Ah, look, that's what I've done. Right, really stupid sign mistake. There you go, minus 6w minus 3 should have been plus 18w. Right, so sorry, everything else should be okay. That was my mistake. So if I go back to the w, sorry about that, I had 9w plus 18w plus 12w plus 3w. 42, that's what I wanted. Sorry about that. And then for the numbers, I've got negative 27 minus 18 minus 9 minus 4 minus 50. That's better. So sorry about that. That's also why I should always show you working, because if that wasn't an exam situation, I would have lost the answer marks, but I would at least have picked up some of the method marks because I did show what I did. It's also why I've left it in. I don't want to re-record this because actually everyone makes mistakes, and being able to go back and correct your mistakes is one of the most important things that you can be able to do. But that's the equation I get from that method, which, where's the first one? Is the same. I fit both of those on? I don't know if you can see, I can't see the screen properly. But look, you can see that they're the same. It's just that it's a different variable because for this one I made a substitution. But whichever method you use is fine. I like this if it's simple, but for more complicated ones, for a quartic one, I would definitely be using this method instead. Because it just gets, all the organisation just gets too complicated for the number of marks otherwise. And that is the end of Roots of Polynomials and the last video. So yeah, well done. If you've made it this far, well done. It's hard, lockdown's been hard and keeping motivated has been really hard. So well done for that, and have a lovely summer holiday.